Hello, my name is Amelia Curia, and the title of my research is Low-Cost Energy Alternatives to Produce Small-Scale Portable Evaporative Desalination.
What is the problem being investigated and the hypothesis of the study?
The problem that I investigated was finding other ways to produce evaporative desalination on a smaller scale, rather than the industrial machines used in major desalination plants, as well as in a way that was cost-viable. Generally, the process of reverse osmosis is used in major plants, which is effective but costly. Furthermore, as graphically shown in Figure 1, the number of people in a water shortage has been increasing over the years, and this problem is looking on the global scale and bringing a large problem to a small scale. Clean drinking water is being consumed as the population grows, and a device that can increase the supply is needed. Products such as the Life Straw on the market today are able to clean water but do not desalinate it. This is where the problem of the lack of devices on the market was brought about. The hypothesis or engineering goal was to be able to use solar energy and or charcoal combustion to facilitate evaporation through an engineered portable chamber bottle, as well as use materials that are upcycled to create the apparatus and evaporative drip reel design.
Why is your research study novel or innovative?
My research is innovative in that it is looking on the smaller scale of desalination in terms of being effective in everyday life for people who want to use ecologically friendly devices, but also have them be cost efficient. Using the solar energy to facilitate the evaporation, as well as an engineered apparatus, the bottle was able to collect desalinated water. The engineered apparatus, modeled after stalactites, allowed for more evaporative drip, which aided in the overall desalination process, as visualized by Figures 2 and 3. The charcoal burner pictured in Figures 4 and 5 was made out of repurposed materials, in this case a cat food can and screws. These materials are able to withstand the heat of the lit charcoal and can be easily replaced as they are in excess from human waste. The upcycling of such materials can promote better ecological awareness in the desalination industry.
What are the key results of your study and how are they applicable?
Following the tests of the study, it was found that the chamber bottle design, in accordance with the stalactite hoop, was able to produce desalinated water under the given conditions. The evaporative cooler statistically did aid in cooling down the bottom chamber versus results without it used in testing for all trials done. Upon using artificial light, it was found that the bottle was able to produce condensation in the top chamber, as well as keep it cool enough for the bottom chamber that was heated. Figure 6 visualizes the trial process without the evaporative cooler, where an artificial light was placed at a constant distance and run to collect data, as well as in Figure 7, when the evaporative cooler was used. For Figures 8 and 9, when comparing the graphical data of all the trials with and without the evaporative cooler, it was found that the cooler was able to keep the top chambers 2.8 degrees Celsius cooler, aiding in the evaporation process. A hot plate and fan was also used in a separate trial to test the effects of wind on the bottle's ability to heat up, and the setup of this trial is shown in Figure 10, with the vernier probes used to record data. The results of those trials concluded that the bottom chamber was still able to produce condensation as graphically expressed in Figures 11 and 12. For the trials done with the charcoal burner, Figures 13 and 14, the bottle was placed on top of the burner with lit embers. The water was able to be heated up 37.6 degrees Celsius from the starting amount, while the top chamber heated up 3.7 degrees Celsius, implying that the evaporative cooler had a positive effect on keeping the top chamber colder than the bottom, as displayed graphically in Figure 15. The bottle's capability was also tested outside using solar energy to evaporate, which is the goal for the real-world application of such an apparatus. This setup can be seen in Figure 16. In Figure 17, the graphical data is displayed of the two chambers against the outside temperature. As the trials concluded, it was found that the best method of low-cost energy alternatives in the natural form was the charcoal burner in accordance with the hoop design. These findings are applicable to real-world application, and that this small-scale bottle can be used on large-scale population to help aid in a global issue. Thank you.